Hello, I'm Chris from HAPP Research. This video series demonstrates how I produce large carbon fiber parts with the do-it-yourself method at home. As a refresher from the videos of steps 1 and 2, here are 2 copies of the upper and lower shells. They're about 1 meter in diameter and weigh about 1,000 grams each. I use a 3-step process to fabricate these parts. First, I build a full-scale model called a plug. I showed that step in the first video. In the second video, I showed how to use the plug to make a mold. In this final video, I use the mold to vacuum form the Aeroshell parts. Okay, before I start laying up carbon fiber, I need to prep the mold. First, I add some polyester release tape along the score lines that were cut into the plug and are now imprinted into the mold. The tape ensures the part won't hang up on the score lines at demolding. Then it's a couple of coats of mold release parting wax. And on top of the wax, I spray some polyvinyl alcohol. The PVA dries to a thin, water-soluble film that provides even more release capability between the plug and mold. Next, I use the CAD model of the HAPP to produce a pattern for cutting the carbon fiber. With the pattern, I can accurately cut sections that can be laid into the mold without wrinkles or gaps. There's the cardboard pattern. Now I cut sections for the outer layer from a honeycomb patterned fabric, and I cut sections for the inner layer from a standard twill fabric. The next question is how to align the fabric and the mold. I use a laser with a cross pattern to demarc the quarter sections. Then, after spraying some mild adhesive, I laid down strips of carbon fiber twill to cleanly cover the overlaps between sections. There we go, perfectly aligned. The outer layer of honeycomb fabric is next. Then I add strips around the upper and lower edges to add strength to the part. And next comes the inner layer of twill fabric. Finally, I add strips to overlap the fabric joints. And I do some trimming around the edges. There it is, the full layup. Perfectly aligned. Beautiful. Okay, now it's time to prepare for vacuum infusion of the resin, and here's the strategy. Start with the mold and carbon fiber layup. Enclose it in airtight plastic. Then we need to somehow suck a bucket of resin into the carbon fiber. How do we do this? By using tubes to connect a vacuum pump to a resin overflow trap, like so, puncturing the airtight seal at the bottom, puncturing again at the top, and connecting to the resin. When we turn on the vacuum, resin is sucked into the fiber and any excess goes into the trap. Easy, let's set it up. On top of the carbon fiber, I put a perforated release film made from a pinkish copolymer. This film separates the part from the other materials I'm about to add. Next is green flow media or mesh that facilitates flow of the resin. At the bottom of the mold, I add some fluffy batting and a spiral tube that will route resin to the 4 outlet ports. You can just see the small white ports. Along the top of the mold, I add more flow media. This one is gray and goes directly under the resin input ports. It helps the resin spread out quickly as it enters the mold. Now I add some vacuum tape, which is thick and gummy. This will form a seal between the mold and the vacuum bag. Using the fabric pattern once again, I cut some green vacuum bagging material. Then I adhere the bag to the mold using the vacuum tape, establishing an airtight seal. We're now ready to prep some tubing. Here I'm assembling the inlet feeder tubes. They use a branched design with a valve to control resin flow. There are 3 feeder clusters with 4 ports each, sufficient to cover the large diameter of the part. I add some outlet tubes to the bottom, and I start cutting in the input ports, sealing each with yellow vacuum tape. At this point, the vacuum is turned on and we're checking for air leaks. The bag is shrunken tightly against the mold, compressing all the layers underneath. Looks good. Houston, we have a solid vacuum seal. We are go to attach the feeder tubes and resin bucket. As a final step, I spray the inside of the trap with the release agent so any cured resin can be extracted, and I attach the vacuum pump to complete the system. Okay, it's go time. Start the vacuum pump. Mix the 2-part epoxy resin. Pour it into the feeder bucket. Open the valves, and we have resin flow. The infusion takes about 15 to 20 minutes from start to finish. I continuously add small batches of fresh resin to the feeder bucket to prevent it from curing too early. You can also see some blobs of resin forming near the inlet ports. The gravity-assisted flow is injecting more resin than the pump can extract, as the direct air channels between inlet and outlet are wetted out with resin. I should have used additional outlet ports, but I carefully massage the blobs down to the outlet and the part looks okay. Okay, infusion is done and now we wait for the resin to cure. This is room temperature resin and heaters are not really necessary, but they speed up the cure significantly, so I insulate the mold with a blanket and place some space heaters nearby. Nice and toasty. With the part cured, it's time to disassemble the setup. The actual demolding is a bit more tedious. First, I peel away the vacuum bag, flow media, and peel ply. At this point, you can see the inner B surface of the actual part. I found it easier to cut away the upper and lower lips, which are not part of the Aeroshell, before trying to extract the part. Then at last, I jimmy the part out of the mold with wedges. Thankfully, it comes out much easier than the plug did in the second video. This is a freshly demolded Aeroshell. Without any touch-up whatsoever, you can see the high quality of the A-surface finish. It almost makes all of that sanding and polishing worth it. Almost. The absolute last step is to do some finishing. Here I'm grinding down little ridges of resin formed by careless wrinkles in the vacuum bag. I'll also trim off the upper and lower mold lips using a Dremel while guided by the imprinted score lines. Well, that's it, folks. Starting with the plug, the elapsed work time is over 49 hours, and that's just for this one upper shell. I have not included design, setup, cleanup, or most of my mistakes in the elapsed time, and I estimate the actual number is about 3 times what you see on screen. I think I've earned one of these. Cheers, and thanks for watching. I hope these videos inspire you to get creative on your own.
I'm Cassie, and I approve this video.